Welcome back. I am Sudipa and today I am going to teach you periodic table, periodic properties and variations of properties. This chapter is included both in the textbook of class 9 and class 10 ICSE chemistry. Whenever we look at the structure of the long form of the periodic table, we are somewhat puzzled like this. I'll try my level best to unravel whatever has been given to us in the periodic table. So let's start off. It is a human tendency to arrange things of the similar kind in some special categories. And that is what has been done by the scientists when they kept on discovering the elements one by one. So what was the basic reason why they started this classification? Classification helps to study the element in an organized manner. It helps to correlate the properties of the elements with the fundamental properties of all states of matter. It also helps to define the relationship of one element with another. But this process has not been easy. In the beginning, this classification of elements was done by certain characters like the density, malleability, ductility, etc. And they kept on classifying the metals and the non-metals under the same heads. But with time, the scientists felt that was not very scientific. So it was in the year 1815 when William Prout concluded that it was atomic mass of an element that never varied. The other physical properties that they used earlier for classifying elements like density, malleability, ductility kept on changing from one element to another. Therefore, William Prout said that let us classify the elements based on their atomic masses. But with time, as the number of elements kept on growing and growing, different scientists came up with the ideas of classifying them based on the triads. Some of them started classifying them based on the octaves and so on and so forth. It was later on Mendeleev who gave us the first periodic table of the elements based on his law, which states that the properties of the elements are periodic functions of their atomic masses. What is the key word in this definition? The key word is periodic function. What does this mean? It means that whenever we arrange the elements in a particular fashion, whether that's a triad, whether it's an octave or the long form of the periodic table, after certain intervals of time, the properties of the elements that are coming under the same columns keep on repeating. That is what is called as the periodic functions. This arrangement enabled Mendeleev to place 63 elements that were known at that time. But right now there are 118 elements that are known to men, of which 94 are naturally occurring and the remaining have been prepared in the laboratories. Later on, Henry Moseley put forward the modern periodic table. So what is the modern periodic table? Modern periodic table is a tabular arrangement of the elements in groups, that is the vertical columns, and periods, that is the horizontal rows, highlighting the regular trends in properties of elements. That is what is called as the periodic table. So just now I was discussing this only, the regular trend. This is called as the periodic function. Now let us look at the structure of the long form of the periodic table that has been given to us. When we observe the long form of the periodic table, the first thing that we should look into is the periods. There are 7 periods starting from 1 to 7 and there are 18 groups in which 118 elements have been put properly. These things that you see below are actually an elaboration of those elements of atomic number 57 to 71 and again from 89 to 103. They have been given a separate position in the periodic table so that the structure of the periodic table remains unchanged. Now this periodic table gives us a lot of information. See, there are different colors that have been used, different symbols that have been used, different Roman numbers and even alphabets that have been used. So we are gradually going to unravel what these things tell us. See, this is the skeletal structure of the periodic table. Now all of us have seen this periodic table umpteen number of times. But do we really know how these periods and the subcategories are arranged? Let us try to see. See, there are 7 periods starting from 1 to 7. And now see how these are arranged. This is 1A, 2A, 3A, 4A, 5A, 6A, 7A, 0, 8. Now let us see the other categories of B. 1B, 2B, 3B, 4B, 5B, 6B and 7B. So we have got the complete 7 periods and 18 groups. When we had seen the periodic table earlier, it often must have seemed to us that they are aligned in a proper sequence starting from 1 to 8. But now we see that the division or the categorization is slightly different, wherein 1A, 2A, and there is a big gap which has been kept for B, and then the 3 to the 0, and again the 8 comebacks, and then we start with the 1B, 2B and so on. Now let us see the lanthanide and the actinide series. I had just discussed that the lanthanide and actinide series are actually part of the long form of the periodic table only, but they have been given a special place. Now we are going to see what the periodic table actually contains. The elements that are arranged in the periodic table either are metals, non-metals or metalloids. The color scheme makes it very clear to you. These are the metals, these are the non-metals and these are the metalloids. Now a very strange thing that may raise a question in your mind is, why is hydrogen being colored as blue? Hydrogen has been colored as blue because it is very similar to the elements of 1A as well as very similar to the elements of 7A. So it behaves both as a metal and as a non-metal. Therefore, it has got a unique position in the periodic table. Now let us categorize the metals and the non-metals by some special names. 1A is called as alkali metal, 2A called as alkaline earth metal, 3A is called as boron family after the name of the first element boron, 4A is called as carbon family after the name of the first element carbon. Similarly, 5th A has been named as nitrogen family after nitrogen, 6th A has been named as oxygen family after oxygen, 7th A consists of the sea salt formers or the halogen, and 0 are the special gases which are also called as the inert gas. Now that we have seen that the elements are distinguished as metals, non-metals and metalloids, let us see what are their characteristics that make them very different from one another. So if we go by the appearance of the metals, we all know that metals are very shiny while the non-metals are dull. The melting points and the boiling points of the metals are very high, and metals other than mercury, they are solids at room temperature while mercury is a liquid. In case of the non-metals, the melting point and the boiling points are generally lower than metals. Bromine is a liquid at room temperature and the others are generally gases. The density of the metals are very high, that is why we feel that the metals are very heavy in comparison to the non-metals which have low density. Therefore, generally they float. The metals are very strong and very much resistant to loads, while non-metals are not so strong and are generally brittle or can break down very easily. Metals are malleable, that means they can be hammered and can be given shapes and can be made into flat sheets, while the non-metals break down very easily when we hammer them. The metals are ductile, that means they can be drawn to make wires, while the non-metal breaks off easily, so they are absolutely non-ductile. Metals are very good conductors of heat and electricity, while non-metals are poor conductor of heat and electricity with the exception of graphite, which is an exclusively good conductor of electricity. Now that we have come to know the properties of the metals and non-metals, we should know about the properties of metalloids. Firstly, what is a metalloid? A metalloid is an element which displays the characteristic both of the metal as well as non-metal. Therefore, they will be shiny or they can be dull. They can behave as a non-metal or they can behave as a metal at times. They can form amphoteric oxides, which means they can behave as basic oxides as well as acidic oxides. They can behave as a semiconductor, unlike the metals which are extremely good conductor and the non-metals which are poor conductors. All the metalloids have different melting and boiling points, so you cannot categorize them like the metals or the non-metals. Some of the metalloids look like metal, solids and tough. So now we have come to know that the 118 elements of the long form of the periodic table can be either metals, can be non-metals or metalloids, and we have seen the properties briefly. Now before I explain you the next part of the periodic table, I just want to put another concept in your mind. We have always been studying the structure of the atom as it has a central nucleus, and around the nucleus are some orbits in which we can see the electron. When we have the study of the atom, actually only there are certain region around the nucleus of the atom in which there is probability of the electrons to be found, and that is called as the electron cloud. And the regions where these electrons can be found are also very specific. They will be found in certain regions, and these regions are called as the orbitals. So in the atoms, we have the s orbital, p orbital, d orbital and f orbital. About the s, p, d and f orbitals, you are going to study in details when you pass out class 10th. But why I introduce this concept of s, p and d to you is because we are now going to categorize these elements into different blocks. What are the names of those blocks? They are the S block, they are the P block and they are the D block. This is the reason why I told you the meanings of the S, D and P blocks, which actually represent the orbitals in which the electrons are present. Now as you can see, we have also categorized the elements into representative elements, transition elements and the inner transition elements. Now let us see one by one what these things actually are. Now the representative elements, as you can see from the color scheme, consist of different colors. That means they are falling under the categories of metals, non-metals as well as metalloids. So basically the representative elements can have their electrons present in the S block as well as in the P block. Now let us study the characteristics of the representative elements. The representative elements include both the metals and the non-metals as well as metalloids. They can form electrovalent as well as covalent compounds with non-metals. Now what these electrovalent and covalent compounds are, I'll explain you in detail when I teach you the second chapter of chemistry, that is chemical bonding. The metallic nature increases as we go down these 7 groups. 1A and 2A elements, that means these two groups, they are very good conductors of heat and electricity. The non-metals of 6 and 7 are poor conductors of heat and electricity. Some of the heavier elements like the tin and the lead, they exhibit variable valencies. Now let us see the transition elements. They have their electrons present in the d orbital. So as you can see, it is totally a region which consists of the metals. Now let us see their characters. These metals have high melting point and boiling point. They are good conductors of heat and electricity, which is a basic property of any metal. They have magnetic properties. They can act as catalyst. I believe you remember what are catalysts. Catalysts are those substances which take part in a chemical reaction and increase or decrease the speed of the chemical reaction without directly participating in that reaction. They may exhibit variable valencies as well. Now let us see the properties of the lanthanides and the actinide series. They are very heavy metals and have high boiling point and melting point. They have variable valencies. They form colored ions, and the actinide series are radioactive in nature. So we have seen the properties of the different types of elements that are present in the periodic table. Now this is a very special group which is named as the zero group, and it consists of the inert gases, as I have already said. Now what are the properties of these elements? They have a complete octet or duplet. Now what is an octet or a duplet? We have studied in our junior classes that an element keeps on reacting continuously with another element. And why does it do so? It does so because it needs to fill up its last electronic shell by either 2 electrons or by 8 electrons. If it completes its shell by 2 electrons, it resembles the character of helium, while if it has 8 electrons, it resembles the characteristics of these other inert gases like neon, argon, krypton, xenon and radon. So when they complete their octet and duplet, that means they don't need to react any longer. And if they don't react, therefore there will be no exchange of electron, neither giving nor taking. Therefore the valency of those elements must be 0. They do not react, and all of them are gases. So these were the characteristics of the zero group or the inert group. So by now we have studied the characteristics of the representative elements, the transition elements and the inner transition elements, and the special group which is called as the zero group. See, according to your textbook, the next part is the salient features of the modern periodic table or the long form of the periodic table, and just now I have discussed in detail about all these elements and their groups, etc. Now the next matter of discussion is periods. I have already told you that there are 7 periods and 18 groups. Now how important is the knowledge of period and group of an element is to us? See, a period is determined by the number of shells and a group is determined by the number of electrons present in the outermost shell. Let us take a very simple example that is given in your textbook, sodium. Sodium has got 11 electrons. So now if we find out the electronic configuration of sodium, there will be 3 shells in sodium. The first shell, that is the case shell, should have 2 electrons, the next will have 8 and the third will have 1 electron. Since the last shell contains 1 electron, it should fall under group 1. And since there are 3 shells in sodium, therefore it must fall in the third period. Similarly, if you consider the electronic configuration of calcium 20, we see that there are 2, 8, 8 and 2 electrons in the 4th shells. The last shell contains 2 electrons, therefore it must fall under the second group. Since it has got 4 shells, therefore it must fall under period 4. This is how, if you are given in the question just the electronic configuration of a particular element, it becomes very easy for you to decide the period and the group. What is it? Period will be determined by the number of shells the element has, while group will be decided by the number of electrons that is present in the outermost shell of that element. Now the next matter of discussion is periodicity. When I had started discussing about the periodic table, I had told you about the word periodic functions. Now I am going to introduce to you another word, which is periodic properties. So what is periodic properties? The properties that reappear at regular intervals or in which there is a gradual variation, that is increase or decrease at regular intervals, are called as periodic properties, and the phenomena is known as periodicity of elements. That means a particular property is going to be repeated after certain intervals of time. And why does it happen, and can we really identify these things? Let us see by some very simple examples. Here I have taken the elements fluorine, chlorine, bromine, iodine and astatine. I have told you what these elements are. These are sea salt formers or the halogens. So now let us look at the atomic number. Fluorine is 9. If you classify it in the electronic configuration, it has got 2 and 7 electrons. Chlorine is 17, so 2, 8 and 7. Bromine is 35, so 2, 8, 18 and 7. Iodine is 53, 2, 8, 18, 18 and 7. Astatine is 85, so 2, 8, 18, 32, 18 and 7. This is the electronic configuration of these halogens. Now what is very similar in them? Look at the last electronic shell. How many electrons do they contain? All of them contain 7 electrons in the outermost shell. Therefore, they must be having certain characteristics which will be common for all of them. Let us now see what those characteristics are. Now as you can see, the number of electrons are continuously increasing as you come down from fluorine to astatine. So it is very clear to us that gradually the size of the atom will increase as we go down the group. That means fluorine should be the smallest and astatine should be the largest. See, the calculation also tells the same. If you talk of the ionic size, I hope you remember what is an ion. An ion is a charged atom. Whenever an atom which is actually neutrally charged loses or gains electron during any reaction, it no longer remains neutral. It becomes either positively charged by losing electron or become negatively charged by accepting electron, and that is why an atom becomes an ion. So if that is the case, if there is difference in the atomic size, therefore the size of the ion must also change. It also increases down the group. These are the value of the atomic radius. If you compare, you can see gradually it is increasing in the same way as the size of the atom has been increasing. Let us see a few more properties. How does a halogen react with hydrogen? Fluorine reacts instantly at minus 200 degrees Celsius. Chlorine reacts slowly in the dark, it explodes in the light. Bromine needs a very high temperature, that is plus 200 degree in order to react, while iodine requires 500 degrees Celsius temperature to react. So it has started with a temperature of minus 200 degrees, then it became the sunlight, then it became plus 200 and now it is plus 500. Therefore, it is very clear that the reactivity gradually decreases from fluorine to iodine. We can see here very clearly that these elements, that is the halogens, are showing periodic properties or are showing a regular change in the characteristics or in the way they react. Now, the next concept is the shell and valency. Now, why are we considering shells, that is the orbits or valency together? It has got a relationship. As I was telling you when I explained you inert gas, that inert gases do not react because they have a complete octet or a duplet. So, where is the complete octet or a duplet? It is in the orbits. The electrons are present in the shells or in the orbits, and the number of electrons present in the shells or the orbits decides the combining capacity of the elements, and that is what decides the valency of that element. Suppose let us take this very simple example again of any of the halogen. Let us take fluorine. I have told you that it should be a complete octet or a duplet. Now see, the last shell contains 7 electrons. It is absolutely not possible for an element to lose 7 electrons and make it a duplet. Instead, it is a preferable choice that it should accept 1 electron and make it an octet, isn't it? See, there are so many examples that have been put here. Hydrogen, it has got 1 electron in its outermost shell. Now, if it has to complete its electronic configuration, the preference that it will give is to complete the duplet and not the octet. Therefore, it has to accept 1 electron and form the duplet. Since it accepts 1 electron, therefore the valency of hydrogen is 1. Similarly, helium, it has got an atomic number of 2. That means it is already satisfied or saturated with 2 electrons. Its duplet is complete, therefore it does not react. See the example of neon. It has got 10 electrons. It is another inert gas. It has got 2 electrons in the K shell and 8 electrons in the L shell. Therefore its octet is complete. It does not need to react. Therefore again its valency is 0. Now let us take another example of nitrogen. Nitrogen has got 7 electrons. Therefore the electronic configuration is 2 and 5. So to make this 5 into 8, it has to accept 3 electrons. Therefore the valency of nitrogen is 3. Similarly, oxygen has to accept 2 electrons to complete its octet. Therefore the valency of oxygen is 2. So when we see the electronic configuration of any element that is given to us, our first thing is we will divide them into K, L, M and N shells, and I believe you remember how it has to be done. It has to be done by the formula 2n square, where n is the number of the shell, and we'll get a distinct electronic configuration. Just by looking at the last shell, we can decide whether it has to accept or it has to give, or there will be no give and take policy. That will decide the valency of that particular element. Now, according to the textbook, the valency depends on the number of electrons in the outermost shell, that is also called as the valence shell. If the number of electrons present in the outermost shell is 1, 2, 3 or 4, the valency will be 1, 2, 3 or 4 respectively. If the number of electrons present in the outermost shell is 5, 6 or 7, the valency should be 3, 2 and 1 respectively. 1, 2, 3 and 4 basically are for the metals, and the remaining ones are for the non-metals. Here there is a simple chart which shows the electronic configuration and how this electronic configuration or the electronic arrangement is going to lead to the formation of the molecules. Like for example, potassium chloride. Potassium has the electronic configuration of 2, 8, 8 and 1, while chlorine has the electronic configuration of 2, 8 and 7. So if they want to satisfy the electronic configuration, it is a very good choice for chlorine to accept 1 electron from potassium. Thereby potassium loses 1 electron to chlorine and it completes its octet. Therefore the compound potassium chloride will be formed. Since potassium loses 1 electron, its valency is 1, and chlorine accepts 1 electron, its valency is also 1. While there is a give and take process of the electrons, there is definitely the formation of the positive and the negative ions, but while we write valencies, we never indicate the plus or the minus sign. Therefore, if you want to make the chemical formula for potassium chloride, it should be K1Cl1. Since it is common for both potassium and chlorine, therefore we can also write as KCl. That is all for this video. My next video will be on the periodic properties and how these periodic properties changed along the groups and periods. Thanks for watching.